right, so I want to start with number 2. And actually, let me put this up here. I circled the ones I want to make sure we get to here. All right, so number 2, so squares of equal size are cut off the corners of a 10 by 14 inch piece of cardboard. All right, I made it cardboard instead of paper, and I changed, the dimensions of it, but this is no different than the one we did in the notes that was the 8.5 by 11 inch piece of paper, right? So what you have is this piece of material, this piece of cardboard or paper here, and you're cutting squares out of the corners and then folding it up to create a box. So the thing is, we don't know how big of a square to cut out. And I'm going to call that distance x, since we don't know what it is. They'll all be the same, so they would all be x. And you're like, hey, but Ms. Cole, we already did this problem. Well, the amount that you want to cut out is going to be different since I changed the size of the piece of cardboard. Okay, so it's going to be a different problem. It's going to go the exact same way, just with different numbers on it. So what is the largest possible volume of the box? So we need an equation for volume. It's going to be length times width times height. So the length of this was 14 inches, but we cut x out of each side. We cut a square out of each side. So it'll be 14 minus 2x. And then the width was 10 inches. But again, we cut a square out of each side. So this distance would be 10 minus 2x. And then when you fold it up, this x distance becomes the height. So the height would just be x. So it's length times width times height. And then you have to multiply all this together. So it's basically just a lot of algebra. All right, so 14 times 10 would be 140. The outsides are going to give us minus 28x, and then the insides would give us minus 20x. So that'll be minus 48x. And then this will be plus 4x squared. All right, and then I'm going to distribute the x through there. Again, just a whole big lot of algebra. 140x minus 48x squared plus 4x cubed. All right, and then the next step is the most important step. What do we do next, guys? Don't skip this step. It is the most important one. What is the next thing we're going to need to do? Good, nice job. Derivative equals 0, perfect. It's the only step that's calculus. This is where we get our critical points, all right? So derivative equals 0. So this derivative would be 140 minus 96x plus 12x squared equals 0. And here's where the calculator comes in, because this does not factor. So we're gonna need to type this in. So if you have your calculator handy, you can go ahead and type this in with me. We're gonna go to y equals, let me clear that one out. And I'm gonna type in this. So 140 minus 96x plus 12x squared. All right, and we'll look at the graph. It's gonna be a parabola. And there are two critical points. The one that we want is this one. That's where we have a change from positive to negative, and we want to maximize the volume. So positive to negative. If you're like, Ms. Cole, I'm not sure I'm going to remember. If you pick this one at the end, when you plug it back in, you're going to get a negative volume, and you'll be like, oh, whoops, it must be the other one. All right, so we're going to get this one. So calculate a 0. Now, it looks like it's right on 2. I doubt that it's exactly 2. I'm sure this is going to be a decimal, but I'm going to make my left bound be 1 enter, and my right bound is 3 enter, and then my guess is 2 enter. So yeah, really, really close to 2. So x is 1.918 inches. And then we have to take that and plug it back in for the volume. Once again, what's really cool is the calculator will do this for you. I'm just going to close back out of here, go back to this original volume equation, and just type it with the x's in there, and it will plug this value in for x for you. So I just typed this exactly like it looks with x and everything. You can just use the variable key. And there's your answer. Make sure you do 3 decimal points. So 120.164. And hey guys, what are going to be the units for that? Remember, it's volume. So what will be the units for this one? Yeah, good. It's going to need to be cubic inches. Area is squared, volume is cubed. Good. Nice job, guys. Perfect. All right, inches cubed. All right, and then number 3, again, this one's really similar to one that we did in the notes. We're going to fence in an area and use an existing barn as one of the sides. And that's so that we only have to do 3 sides of fencing. So here's the barn, and we're going to just do 3 sides of fencing. And so what we want to do is find the largest possible area. So we want to maximize area. So I need an equation for area that would be length times width, so x, y. And the issue is you have 2 variables. So I'm going to need to come up with another equation so I can substitute one of them out. So let's see. It's how much fence do we have? 300 feet of fencing are available. So if I add up these 3 sides, which will be x plus 2y, that's going to be 300. So I have 300 feet of fencing available, and it's easier to solve for x here. So I'm going to subtract over the 2y, and then that gets plugged in for x. So this will be area equals 300 minus 2y times y. And then we're going to distribute the y through there. And then please don't forget the most important step. It is the only step that is calculus. The rest of this is just algebra so far. It's just getting an equation and substituting something in. Don't forget to do derivative equals 0. That's what gives you your critical points. It's the most important part. So this will be 300 minus 4y equals 0. And so I'm going to subtract the 300. Negatives are going to cancel and divide by 4. What is it going to be? 75. And what were my units? Let me see. 75, was it feet, yards? But I have feet. All right, so 75 feet. So y is 75. So both of these are 75. I still need x. I'm going to take 75 and plug it back in right here for y. So 75 times 2, that would be 150. 300 minus 150 would be 150. And then the area is x times y. So 75 times 150, that is 11,250. And this is an area, so it will be square feet. So volume is cubed, area is squared. All right, so those are the 2 that you get a calculator for. All right, so non-calculator ones. Number 4, do the following functions satisfy Rolle's, the hypotheses for Rolle's theorem on the interval -2 to 5? So let's review those. Remember when I taught this? I know this was like 3 weeks ago at this point. We got out the highlighter and we highlighted all of the conditions. You can go back and watch the notes on it. It's in that Zoom meetings folder. Rolle's had 3 conditions. You have to be continuous and differentiable, and you have to start and end at the same place, okay? So let's check each one of these. So letter A, that is gonna be an issue. An absolute value is gonna have a sharp edge. This one's gonna have a sharp edge at 4. If you wanna think of that from a graphing perspective, it would look like this, it moved right 4. And 4 is on this interval. So this one's not differentiable. So that one's gonna be a no. All right, letter B, This is a parabola, so that's continuous and differentiable. We just need to see if we start and end at the same place. So I'm going to plug in -2, and I'm going to plug in 5. And it doesn't matter what they come out to. They just have to be the same thing. So let's see. -2 squared would be 4. -2 times -3 would be 6. So 4 plus 6 is 10, minus 10 is 0. And if you plug in 5, that's going to be 25 minus 15 minus 10, which would be 0. So yes. And then the last one, again, this is a polynomial, cubic, so it's going to be continuous and differentiable. We just need to see if we start and end at the same place. So -2 cubed, that would be -8. Double that is -16. And then this would be +10, so -6. And then if we plug in 5, okay, 5 cubed is 125, and then we're going to double that. So without even going any further, I know that this answer is not going to come out to -6. Whatever it is, it's not -6, so that's a no. So it's continuous and differentiable, but it doesn't start and end at the same place. So next one I want to look at. So number 6, does this function have a value c in this interval such that f of c equals 0? Justify your answer. So a justification, this is going to be a sentence that we're going to write. So Yana, you're going to have to write a sentence here. And this is going to be intermediate value theorem. We're going to show that 0 is in between the other two values. So we're going to plug in -2, and we're going to plug in 3, and we're going to show that 0 is in between them. So if we plug in -2, that's going to be 4 plus 10, so 14. And if we plug in 3, that's going to be 9 minus 15, so -6. So 0 is in between those. You just need to also mention, oh, there, you wrote it in the chat. I was just about to say, you also need to mention the condition, which is that the function is continuous. So we're going to say, here's your sentence. Since f of x is continuous on -2 to 3, and now you can be as wordy as you like here, but you need to say something to the fact that 0 is in between these two values. So the most succinct way to put it is f of 3 is less than 0 is less than f of -2. 0 is in between these. Some people don't like doing the math notation though. They like to write it out in words. Like if you're more of an English person than a math person, you can write 0 is in between f of -2 and f of 3. Like that's totally fine as well. Just, it's a little more writing, but it means the exact same thing, right? So since this is all true, then you can turn the words back on the person that asked you the question. You can just basically recopy the problem. So since all this is true, there is a value c on -2 to 3 such that f of c equals 0 by intermediate value theorem. And you can abbreviate that, IVT, intermediate value theorem. And this is like citing your source. That's like in a bibliography when you're like quoting somebody. Like this is the theorem that we use. So since all this is true, and then this part, again, just recopy the question basically, and it's by intermediate value theorem. So yeah, that one's a little bit of writing, but you know, sometimes life is like that. All right, number 7. Find the relative extrema of this function. All right, so derivative equals 0. Oh, I need to actually find the derivative first though. All right, so derivative equals 0. Derivative of e to the x is, oh, hold on, let me see in the chat. Yeah, basically copy paste the question. Well, this first part comes from you, and then the second part is, yeah, just basically copy paste the question. Yeah, do that. I mean, that will get you the points on the AP exam. Just repeat what they said. Like, therefore, all this is true. All right, so derivative of e to the x is just e to the x. It just so happens to be negative. So negative e to the x plus derivative of x is 1. -3 is a constant, so it's gone. And we're going to set that equal to 0. All right, so I'm going to add this e to the x to the other side. rid of this. This is falling over here. And then just like when we had ln and we canceled it out with e, to cancel out e, we're going to do ln. So we're going to do ln of both sides to get that to cancel out. And hey guys, what's ln of 1? Because that one we do need to know without a calculator. They will bring that. Perfect, nice, good job guys. 0, ln of 1 is 0, so x is 0. Now the question just said find the relative extreme, so we don't know whether it is a maximum or a minimum. So I'm going to need to make a number line for this derivative. If it changes from positive to negative, then it's a maximum. If it changes from negative to positive, then it's a minimum. So we need to check. So if we pick a number smaller than 0, like -1, all right, I don't know what e to the -1 is off the top of my head, but I know it's going to be some decimal. I know it's going to be a fraction. A negative exponent, you know, flips this over, so it's going to be 1/8. It's going to be 1 over e. That's what e to the -1 is. So that's going to be some fraction. We're going to make it negative, and then we're going to add 1. So this is like a really teensy tiny number, like a decimal. Again, I don't know exactly what it is, but if I add 1, that's going to end up being positive. And if I pick a number bigger than 0, like if I pick 1, e to the first, that's about 2.7. If I make that negative, it's -2.7 plus 1, that's going to be negative. So we have a change from positive to negative, and that means relative max. And 0 is just the location. If you want the actual point, you have to take 0 and plug it back into the original problem, which my paper fell down here, so let me pull that back up here. We're going to have to plug 0 back into this. So if we plug in 0, e to the 0 is 1. Anything to the 0 power is 1. We're going to make it negative. So -1 plus nothing minus 3, that would be -4. So here's your answer. We have a relative maximum at 0, -4. All right, and then number 9 is the next one I want to look at. I'm trying to get through as many of these as possible. I want to do like as much of the study guide for you as I can. I know review days aren't super fun. Thanks for hanging in there with me. I want to do as much of this as possible for you, especially since we just had a 2-week break. All right, so let f of x be a polynomial function. F of 3 equals -1. All right, cool. That just means you have the point 3, -1 on your graph. The derivative is 0. All right, if the derivative equals 0, what does that mean about this point? If its derivative equals 0, what can we call it? What's our vocabulary word for that? Derivative equals 0. It means that that point is a what? Good, nice job, critical point. Thank you, perfect. All right, and then second derivative is -4. All right, don't get hung up on the fact that it's -4, just the fact that it's negative. If your second derivative is negative, what does that mean your function is doing? Pull out your sticky note that I told you to make. If second derivative is negative, what does that tell you about the function? Good, nice, concave down. So like this. So if you have a critical point and your function is concave down, that means it has to be this point right here. And so what can you describe it as? What does this point have to be? If your graph is concave down, then what can you say about this point? Good, nice, perfect, relative max. Good job, cool, nice guys. All right, number 10, find the absolute maximum and minimum. I think I'll probably just get you started on this one because I'm going to post all the answers. Absolute maximum and minimum means candidates test. So your candidates are your endpoints, which will be these two, and your critical points, which is derivative equals 0. So this derivative, we're going to bring the 3 down, and it's going to drop to a 2. All the inside stuff, like all the guts of the problem, is going to stay the same. This is our chain rule. So I brought the 3 down, all that stayed the same. Now it's squared, and we're going to chain on the derivative of that stuff, which would be 4x plus 4. We're going to set that equal to 0. So we're going to set each of these factors equal to 0 separately. I'm going to ignore the 3. If I divide over a 3, 0 divided by 3 is still 0. And I'm going to ignore the squared. If I square root 0, it's still 0. So you can basically ignore that. That's what's great about 0. All this stuff goes away. So we're going to set each of these equal to 0 separately. And solve them. So this one, we can factor out a 2x. We'll be left with x plus 2. And so this gives us 0, and this gives us -2. And then this one, if you subtract over the 4, that would be -4 divided by 4 would give you -1. So these are your 3 critical points. What you're going to need to do is make a chart for the original function. So this one right here, and you're going to test your end points and your critical points. And so I'm going to leave the rest of that for you guys to finish. You would take these, plug them back into the original function, and then write out what the biggest and the smallest are. So you're going to have absolute maximum is whatever at x equals whatever. And you're going to have absolute minimum is whatever the smallest result is at x equals wherever that happens. So you would plug those into the original function, see what you get, and then write out your answer. Now it says, oh, it doesn't say justify. Well, if it says justify, the chart acts as your justification. So there's not like a sentence that you need to write there. The chart is your justification for that. Oh, this one should be no work. I don't want anyone to do any work for this. 2 positive numbers have a sum of 18, find their largest possible product. All right, if the sum is 18, what are the 2 numbers? If they add up to be 18, what are the 2? Yeah, 9, good. And so the product would be what, guys? Yeah, 9 and 9. So what's the product? Like, what's the answer? 81. Perfect. All right, no work for that one. That's like a gimme question. All right, number 13, consider this function on -8 to 0. Does this function satisfy mean value theorem on the indicated interval? Circle the correct response. Well, I'm not going to write on the paper so I can reuse this with my other class, but that would be a no. And letter B is if it's yes, do the problem. If it's no, say why not. So why is this not okay? Why can't I do mean value theorem? Like, what's the problem with the absolute value graph? Good, yes, perfect, sharp point. So we're gonna say not differentiable, and you can abbreviate, at x equals -3. That's important because this graph moved left 3, so it's happening at -3. The reason that's important to say is because -3 is on this interval. Say this interval was like 2 to 7, then it wouldn't even matter about the sharp edge because that's not part of the interval, but -3 is on there, so that's why that's important, right? Not differentiable at x equals -3 due to sharp edge. And so you don't even have to do the problem. All right, and then 14, I'm going to give you another one of these. So this one we're going to actually do the problem. So does this satisfy mean value theorem? This function is continuous and differentiable, so yes. And so then you have to actually know what mean value theorem is. Think of mean meaning average. Mean value theorem, it is where average rate of change equals instantaneous rate of change. So that's slope equals derivative. Average rate of change is a slope. Instantaneous rate of change is a derivative. Here, let me write the function down so I can get rid of this piece of paper here. All right, so first let's do the slope. Slope means we need 2 points. So I'm going to plug in -4 and I'm going to plug in -2. So if we plug in -4 cubed, that would be -64. And then -2 times -4 would be +8. So -64 plus 8, that would be -56. And then if we plug in -2 cubed would be -8 plus 4 would be -4. All right, and so our slope, -4 plus 56 over -2 plus 4. A ton of negative signs there, so just be careful. So this would be 52 over 2, which, oh gosh, what is that going to be? 26. So our slope is 26. So you get your 2 points, do slope formula, get your slope. Sorry, my pencil just ran out of lead here. All right, and then we're going to do the instantaneous rate of change, which is the derivative. So this derivative would be 3x squared minus 2. That's the easiest part. And then you're going to set these equal. So this is the average rate of change. This is the instantaneous rate of change. We're going to set them equal and solve it. So this is one of those rare times you don't do derivative equals 0. You do derivative equals whatever your slope was. That's the common mistake I get on this is people will set it equal to 0. And I totally get why that happens. But make sure you set it equal to whatever that number was. All right, so we're going to add over the 2. That'll be 28. Divide by 3. And then we're going to square root. Now, typically you put plus and minus for a square root. But here we need to decide which one we want. Do we want the positive or do we want the negative? And in this case, we want the negative square root. And the reason why, or actually, let me ask you guys, if no one can figure it out, I'll tell you why, but how come we want the negative one, guys? Why would we want the negative answer instead of the positive answer? Yeah, good, awesome. It's the one that's in the interval. Our interval is -4 to -2. So the positive version of this answer is not going to be in the interval. So that's going to be outside the interval. All right. The other one I wanted to look at was number 18. Gosh, I had really wanted you guys to get to work in your breakout rooms on this, but I only have 15 minutes left and I want to make sure I give you all the answers. So I think I'm just going to go ahead and do it. I'm sorry because I know that that's boring, but I want you to have all the answers. So I'm sorry. I am going to just go through this for you because, gosh, we just never have enough time. Calculus is like that. All right, I'm going to go through 18 and then we'll be done here. All right, so this one, I'm going to lead you through the entire process. First derivative test, second derivative test. We're going to just do the whole thing. All right, so find the critical values. That is derivative equals 0. So if I bring down this 4, half of 4 would be 2. So 2x cubed minus, here if we bring down the 3's cancel. So minus 8x squared plus 8x. And then the 1 is a constant, so that's gone. All right, so we can factor out a 2x. That'll leave us with x squared minus 4x plus 4. And then that is going to split. And that'll be x minus 2, x minus 2. So, hey guys, how else can I write that? If I ended up with x minus 2 times x minus 2, how else can I write that to like simplify that down a little bit? Yeah, good. Nice job, guys. And you guys even deal well with having to type stuff in the chat. That's weird. All right, so x minus 2 squared. And so we're going to get 2 critical points. This one is going to give us 0. You guys rock. I so appreciate you typing in the chat for me. It makes me feel not alone here. All right, and then this one gives us 2. So those are our critical points. All right, so letter B. Letter B is find the intervals where the function is increasing and decreasing. So we are going to make a number line for each one of these. So we're going to have a number line for 2x and a number line for x minus 2 squared. So this one gives a critical point at 0. This one is at 2. If nothing weird happened, it's going to be negative and then turn positive. But in this one, something weird happened. There's a squared. What am I going to put in the whole way across here? Because there's not going to be a change. I'm just going to be able to put in what the entire way across. Yeah, good. Nice job. Pluses. Anything squared is going to be positive. So the only place to have a change is right there. You can slice this apart if you want, but it's not going to change. This side's negative and this side's positive. Now, when you do the sentences, it's been a while since we did this. Remember, it should start f of x is or f of x has, because f of x is the function you're talking about. So f of x is increasing 0 to infinity because f prime is positive there. F prime is your source that you're citing. He's the guy that you're quoting. And then the sibling statement is f of x is decreasing everywhere else for the opposite reason, but you still have to write it out. It would be negative infinity to 0 because f prime is negative there. So this is like your answer, these sentences here. All right, so letter C, for each critical point, we're going to write a statement, whether there's a relative maximum, minimum, or neither there. So we're going to have 2 sentences, one for 0 and one for 2. All right, so at 0, we have a change from negative to positive. So what does negative to positive mean? Relative maximum or minimum? If we do negative to positive. Good, nice job, minimum, because it means the function changed from decreasing to increasing. So that's going to give you a low point. All right, so remember, start f of x is or f of x has. All right, f of x, oh, whoops, this one should be has. F of x has a relative minimum at x equals 0 because f prime changes from negative to positive there. So yeah, you have to write a sentence, okay? Now at 2, there's not a change. So that one's going to be neither. So f of x has neither a relative maximum or minimum at x equals 2 because f prime does not change sign there. And you're like, what is all this writing doing in my math class? Well, you have to view it as an essay, your essay writing and justifications for the math that you're doing. But remember, the sentences go the same all the time. And like I keep saying, these answers, like I'm pretty much giving you the answers to the test. Like these are the answers. I can't change them. They're definitions. So it's going to go, like the numbers are going to change, but these are your test answers because this is, a minimum is derivative changes from negative to positive. Maximum is from positive to negative. It's not going to change, promise, right? All right, letter D, points of inflection. So that's going to be second derivative. Here, let me write the first derivative again because I had to flip the paper. What was the first derivative? All right, so here was our first derivative. Mathematically proven cheat. It's not cheating. They're definitions, it's not a cheat. It's just the truth. All right, so inflection points are second derivative. So we're going to do the derivative of the first derivative. So this would be 6x squared minus 16x plus 8. And I'm going to go through and divide everything by 2. So that would be 3x squared minus 8x plus 4. And then that's going to split. So that would be 3x and 1x, 4, I think that's going to be 2 and 2, and they'll both be negative. So I get 2/3 and I get 2. Now here's the thing. When you find critical points, it's derivative equals 0, and that's the answer, period, end of story. For inflection points, these are only inflection points if there's a change there. So we're going to do our number lines and check them. Spoiler alert, they're both going to be inflection points. But just to do the number lines here, just to be real thorough. This one's going to have a change at 2/3. This one's going to have a change at 2. And nothing weird happened. Nothing's backwards or negative or squared. They're both going to be negative and then turn positive. And if that bothers you, you can always pick a test number. Pick a number to the left of 2/3, to the right of 2/3, plug it in and see what you get. If we split up our number line, here we have a negative times a negative, which will be positive. The middle section will be negative, and then this will be positive. So since they both have a change, they are both indeed inflection points. That was part D. And then the last one, state the intervals where f is concave up and concave down. And we already did all the work. The number line is right here. So make sure you start your sentence with f of x is or f of x has. All right, so f of x is concave up on these two sections. So negative infinity to 2/3 and 2 to infinity, because second derivative is positive there. So make sure you cite your correct source. And I have to be able to tell that you've written f prime or f double prime. So, I can read pretty much any handwriting, but don't make this part sloppy, because I need to be able to tell which derivative you're talking about, or I can't give you credit, because that's, it's the second derivative test. I need to be able to see that you had second derivative there. All right, and then f of x is concave down from 2/3 to 2, because second derivative is negative there.